Hi everyone. In today's lesson we're going to talk about how to factor by grouping. We usually factor by grouping when we have an expression that has 4 or more terms. So let's write that on top. Use when you have 4 or more terms. And the best way that I can explain how to do this is if we do an example. So let's look at the first one. I want to factor this expression. It has 4 or more terms, so we're definitely going to use grouping. Is there a GCF that you can pull out of all 4 terms there? The answer is no. There's no number or letter that I can divide out. So now what we're going to do is we're going to separate this into groups of 2. So these first 2 and then these second 2. So I want you to pretend like all we're doing is focusing on these first 2. I'd like to take out the GCF between x to the 6th and 2x to the 4th. You should be telling me I should have a GCF of x to the 4th. After I do that, I should be left with x squared minus 2. Okay, now I want to take a look at the second part, and I want to find a GCF between 3x squared and negative 6. You should be saying I could take out a GCF of 3. Now, do I take out a positive 3? Do I take out a negative 3? You want to look at this middle sign and bring it down, and that will tell you whether to take out a positive or a negative. So I'm going to take out a positive 3, and I'm left with x squared minus 2. Now, you're going to see that both of these parentheses are the same. That, believe it or not, is a GCF that we're going to take out again. So my final answer is x squared minus 2, parentheses, x to the 4th plus 3. So I know that last step's a little bit confusing, but basically, when you factor by grouping, these two parentheses should be the same. If they are the same, then you did it correct, and you're going to basically combine both of these into one parenthesis here, and then take the leftover pieces, the x to the 4th and the 3, and put it right here in a new parenthesis. And that's it. Alright, let's try another one. So example number 2 has 4 terms. There's no GCF that I can pull out of all 4 terms, so I'm actually going to factor just these 2 and these 2. So let's look at the first 2 terms. What's the GCF between these? You should be telling me 3x squared. And what are we left with on the inside? 2x plus 1. Now, what is the GCF between 2 and 1? You should be thinking, well, nothing. I mean, the only thing you can divide both of those by is 1. So we're actually going to do that. Again, whatever sign is in the middle is the sign that we take down. So we're going to take down a positive 1. And when you divide 2x plus 1 divided by 1, we're left with 2x plus 1. Now notice, inside the parentheses should be the same, which they are. So that gets one parenthesis. And then the next parenthesis is made up of this piece and this piece. So 3x squared plus 1. Final answer. Awesome. Let's see if we can do example number 3. Now, do you notice a GCF that you could pull out between a 10, a 15, a 6, and a 9? You should look at those and say, hey, maybe I could divide it by 2? I don't think so because this is 15. Maybe a 3? No. Alright, so it looks like no GCF. I tried. So we're going to break it up into these 2 and these 2. Why don't you take a minute and see if you can factor this and pause the video and then resume when you've finished. Okay, here's your answer. You should have taken out a GCF of 5x squared and you were left with 2x minus 3. Bring down this plus sign and you are taking out a GCF of 3 and you should have been left with 2x minus 3. Now these 2 were the same, so they get their own. And 5x squared plus 3 is the last part. Okay, that's it. Okay, why don't you try number 4 on your own and then hit resume when you've done so. Don't cheat, actually do it. Okay, here's your answer. Your GCF between the first 2 should have been x squared, and you'll be left with x plus y. And now your GCF, this one, is a little different. Your GCF is a negative. So make sure whatever sign is, that's the sign you're going to bring down. So it's a negative y squared. And when you divide xy squared by y squared. These negatives are going to cancel, and you'll just be left with x. Now how about over here? We have a negative y to the third divided by a negative y squared. So that actually becomes a positive y. So look, these two are the same. So they're going to get their own parenthesis, the x plus y. And then we're going to take these two leftover pieces and make a new parenthesis. So x squared minus y squared. Now, you'd hope that this would be the final answer, but actually, does anybody recognize dots here? It's a difference of two perfect squares. So this is actually x plus y, x minus y, and the x plus y in front. Now that's your final answer. So if you'd like to highlight that, there you go. Okay, before we do 5 and 6, there's actually a typo on both of them that I'd like to correct before we begin. So please cross off 5 and 6 as is, and please rewrite these two following equations below. Pause the video if you need to copy them down, and then hit resume when you're ready. Okay, so I know questions 5 and 6 are a little bit more challenging because there are more terms. To be exact, there are 6 terms. To be honest with you, you're just going to do this the same exact way that you would anything with 4 terms. You're just going to group sets of 2. So you're going to group these two, and then these 2. Same thing over here. You'll group these 2, and these 2. So let's start with this first problem. What's the GCF between x to the 5th and x squared? You should be telling me x squared. And you're left with x to the third minus 1. Now what's the GCF between negative 9x to the 4th and positive 9x? Well, because of this sign here, this is the negative, so we're going to take out a negative of whatever you think it is. So I believe the GCF is 9x, and then what's left on the inside is x to the third minus 1. Why is it minus? Because I have a positive 9 divided by negative 9, and that's why you have a negative 1. And we're going to bring down this positive and take out a 14, and we'll be left with x to the third minus 1. Sorry, this should have been a minus in here. That's why it's wrong. Okay, so now what do you notice? That all 3 of these are the same. So that becomes its same parentheses. And we're going to put this piece, and this piece in another set. So x squared minus 9x plus 14. So before we factor a little bit further, I just want to review the steps. So we group the first 2, and then the second 2, and then the third 2. We find the GCF of each of the pieces, and we divide them out. We're also going to make sure that we account for any negatives that are here, so we make sure we divide out a negative. So again, a positive 9 divided by negative 9 gives me this negative 1 in here. And then we recognize that all the parentheses were the same, so those 3 come together to form one parenthesis, and all the leftover pieces form another. Now you're going to hate me, but I can factor all of these pieces again. This here is a trinomial with a being 1, so I can actually use the AM method. So I need numbers that multiply to 14 that add to negative 9. And those factors are x minus 7 and x minus 2. And this also can be factored a little bit more. This is a sum and difference of cubes. So for the SOAP formula, remember, it goes like this. I'm going to put it down here because I'm going to run out of room. It goes a, b, a squared, b squared, and ab in the middle. And your a, remember, it goes x to the third minus 1 to the third. We basically have to write it as something cubed minus something cubed. And the signs are going to be the same, opposite, always positive. So in here we're going to take a, which is x. So this is your a, and this is your b. So x goes here, 1 goes here. Then in here we're going to take a and square it, so x squared will go in here. And then the back end we're going to take b and square it, so we'll get 1. That'll go here. And in the middle we're going to take a and b and multiply them together, so x and 1 is just 1x. So your final answer is technically this. So we factored this by SOAP and got this, and we factored this trinomial and got these two pieces. So you put it all together, and that is your final answer. I know this was a very annoying problem, but let's see if we can do number 6 all on our own. So pause the video, try it, and then hit resume for your answer. Okay, here it is. Okay, if you didn't get this, please pause the video and copy it down, and then I'd like to go over it. Okay, so basically what I did was I took the GCF out here in all of the pieces, and this is what I was left with. Now you want to make sure that when you did this term, you did a negative 80 divided by a negative 10, which gives you a positive 8. Okay, so once you take out all the GCFs, you get here. Now you should notice that all the parentheses were the same, so those came out in front here. And all of the missing pieces, or the leftover pieces, went in its own parentheses here. Then I said to myself, I could factor this trinomial using AM. I needed numbers that multiplied to 24, but that added to a negative 10. So I was able to find negative 6 and negative 4. And I have x squared, because it has to multiply to x to the 4th. I did notice that x squared minus 4 was a dots problem, so that's how I got x plus 2, x minus 2. And this x squared minus 6 is not a difference of perfect squares, because 6 is not. Then I realized I could factor x to the 3rd plus 8 using SOAP, and the numbers that I broke it down into were x to the 3rd and 2 to the 3rd. So following the same pattern that I did over here, this is where I got this from. So I know it's a lot to digest, but take a minute, write down any questions that you may have, and please make sure to ask in class tomorrow. All right, have a great night.